go. How many have you written? No one. Formula I am asking. Come, Yashashvi. Come. Come, don't worry, come. Is this correct? Is there any student? No, sir, it is wrong. Rohit is NO3. Okay, 3. Nitrate. Whenever NO3 is there, nitrate. NO2 is there, nitrate. Okay, so you have to take care about these spellings there itself. There is important. Nitrate and nitrate. Sulfate, sulfide. So this is the basically cobalt nitrate. Why she has written the 2 here? Because cobalt valence is the 2 I have given. The valence of nitrate is the 1. Okay, basically it is the plus 2. This is the minus 1 it is. Okay, so NO3 should be 2 number, cobalt should be 1 number. It is a polyatomic ion. So whenever the polyatomic ion is coming more than 1, what you have to do, you have to keep the bracket and you have to write this one. So what is there, no need to put the bracket. Writing chemical formulas are very, very important as long as you study chemistry. Again and again I am saying, if you don't understand the chemical formulas, you will not understand the ions, what ions that is giving. If you don't understand the ions, our next upcoming topic, ionic equilibrium, you can't understand anything. So each and every topic in the chemistry is interrelated. If we put this into the water, for example, if we put this into the water, what ions it will give? Can anybody tell? Which ions it will give? I am putting this into the water. Which ions this will give? Stand up. CO minus. Okay. NO3 2 plus. Is it so? Yes, I am. What do you think? This ions only. Yes. Yes, Yashashwini. What ions this will give?
NO2 and N2, sir.
NO2?
And N2.
Again you are going with NO2. Then it is NO3. It is there. Can anybody tell? Yeah. This is the important thing to understand. Like, see, magnesium chloride you have added. What you have added? Magnesium chloride you have added. So what ions this will give? Cl minus, okay. Mg? 2 plus. Then how here it would be CO minus? Which plus?
CO2 plus.
CO2 plus. CO2 plus. Okay, so that you have to understand. This is only the balance of that one. So that ion that will give. Which ion that will give? CO2 plus. NO3 minus. Here NO3 charge. What is the charge here? Minus 1. What is the charge on this cobalt? Plus 2, minus 1. But how many nitrate ions? Nitrate ions are there? 2 nitrate. That means that 2 into minus 1. So 2 into minus 1 equal to be minus 2. So plus 2 minus 2, 0. Plus 2 minus 2, 0. Molecules are the neutral basically. But when you put that into the water, that gives this ions, CO2 plus ion and NO3 minus ion. So this CO2 plus ion, whatever it is there, this CO2 plus ion, whatever it is there, if we add to that water, if we add this one to the water we are adding. So even water also can react here. Here complex compounds will form, that is called the coordination compound, which you will study in class 12 in detail. One of the chapter is dedicated for this one. Okay, so what complex here it forms? COH26, CO, you can see H2O6 like this. H2O6 and here charge is the 2 plus because counter ion the two nitrate ions will be here as a counter ions, as a negative charge. So this complex is called the complex compounds, or we call it as a coordination compound. What we call coordination compound. Little bit idea you take, no need to go in detail, okay, how these are forming and all, because this type of examples will come frequently in the chapter of equilibrium. Is it clear? So this is what the cobalt complex. Now, what we will do, we will dissolve this into the water first. We will make this solution. Then, to this one, we will add HCl to this one. What we will add? HCl. So, if we are adding HCl means, what ions that will give? Arsenic. If we are adding HCl into the water, so what ions that will give? H plus Cl minus. So this Cl minus ions will react with this positive ones. This Cl minus ions will positive. So this is the Cl. Okay. Now here this is one of the equilibrium reaction. This is one of the equilibrium reaction. So here what products it will be formed here? CO, Cl4 2 minus. Okay. COCl4 or 2 minus. So this is also one of the coordination compounds. COCl. This bracket indicates for the coordination compound. COCl4 2 minus, and you will have the water here. What you will have? Water. How many number of waters? 6 number of waters. This reaction is equilibrium. That means that you can't furtherly convert into this forward direction. You can't convert this into the 100% into the backward direction. But you can take to the maximum, like 90% conversion or 80% conversions. You can do by doing some changes of the concentrations. Yes, Neeraj. Tell me now, by increasing what I can make this reaction into the forward direction? By doing some change, I can concentration terms I am talking about. So if I do some changes of the concentration, so this is a reaction basically, okay, this you don't consider, this only you consider. Now you tell me, by increasing something, I can make this into the forward direction. So what I have to increase? The reactants I have to increase or products I have to increase to make this as a forward direction? Huh? Reactants I have to increase. Okay. So this anyhow, this will be water. I will increase this Cl minus and I will get this as a product. Maximum percentage. Okay. So what is the color of that compound? What is the color of this compound? Blue. Very smart. Blue color. Okay. Why? Because I have written with blue color. So what is the color of this one? Pink color. So we will see that color changes. Then you will have this some more idea. Okay. Now what we do? We will add this cobalt nitrate, which will have the ions. Basically, this chapter is, if you go to the competitive exams, this chapter is 2 parts: chemical equilibrium and ionic equilibrium. 2 chapters you will study. Here in 1 chapter, board, more advanced board is. So that's why you are reading this as a 1 chapter. Okay, so you should learn. Whether this is the expensive or not expensive, that doesn't matter me. Okay, these are the salts of cobalt nitrate. What about? Open it. Open this. Here now ions are not possible. Unless until you dissolve that into the water, ions are not possible. Dissolve this. Now cobalt H2O6 is formed in this one. What is formed? Cobalt H2O. what I will do, what we have to do now? We have to add HCl. Okay, so it's at equilibrium. Huh? Now I will add concentrated this HCl. We'll see whether the color will change or not. Color has changed now. Okay. So what is the color? As I said, this is the color of this one, blue color. Now, if I want bring this back to this side. Now it back to the pink color. I can make this dance reaction, huh? If I color changes. So where is it here? This one. If I add this one again, blue. This is only basically Le Chatelier principle talks about. Equilibrium C talks about. If you want to make this, for example, this is a drug. If we are doing equilibrium reactions, if we are not changing anything, so that will be the loss for the industry. So if you are doing some changes like decreasing the temperature or increasing the temperature or increasing the concentration, so you can get the more yield there. So this is what the, hope you understand now, concept is clear. This is very important topic for even the competitive exams also. Did you understand? Thank you.